Let yourself relax as we journey through the remarkable story of human evolution. A tale that spans millions of years and takes us from the ancient forests of Africa to every corner of our beautiful planet. Close your eyes and breathe deeply as we explore the fascinating path that led to humanity as we know it today. Imagine yourself drifting back through time, through countless generations, to witness the gradual transformation of our ancestors. This is a story of adaptation, survival, and the incredible resilience of life itself. Our journey begins approximately 7 million years ago in the lush, verdant forests of Africa. The climate was warm and humid, and dense canopies stretched as far as the eye could see. Here, in these ancient woodlands, lived the last common ancestor we shared with modern chimpanzees. These early primates moved through the trees with remarkable agility, their lives intertwined with the forest canopy. They were not yet human, but they carried within them the seeds of humanity. As you relax and let your breathing slow, picture these distant relatives, so different from us yet connected by an unbroken chain of life that stretches across the ages. The first significant step toward humanity came when some of these primates began to spend more time on the ground. Climate changes were causing the forests to shrink, creating more open woodlands and grasslands. This environmental shift presented both challenges and opportunities. Those individuals who could navigate both the trees and the ground had access to new food sources and could explore new territories. Over countless generations, natural selection favored traits that made bipedal movement more efficient. The ability to walk upright on two legs became one of the defining characteristics of our lineage, setting us apart from our ape cousins who remained primarily tree-dwelling. Walking on two legs brought numerous advantages that shaped our evolution in profound ways. It freed the hands for carrying food, tools, and eventually infants. It allowed our ancestors to see over tall grasses, spotting both predators and prey from a distance. It was more energy efficient for traveling long distances across open terrain. And perhaps most importantly, it set the stage for other evolutionary changes that would follow. The skeletal structure began to transform, with the spine developing its characteristic S-curve, the pelvis becoming broader and more bowl-shaped, and the foot developing an arch that acted as a shock absorber. These changes didn't happen overnight but gradually, over millions of years, each small modification building upon the last. Around 6 million years ago, the genus Sahelanthropus emerged, known from a beautifully preserved skull found in Chad. This ancient hominin already showed some features suggesting bipedalism, though scientists continue to debate the extent to which these creatures walked upright. The skull, nicknamed Taumai, meaning hope of life in the local Goran language, gives us a precious glimpse into this transitional period. As you sink deeper into relaxation, imagine the world of Taumai, a world without cities or agriculture, where survival depended entirely on reading the natural environment, on knowing which plants were safe to eat, where water could be found, and how to avoid the numerous predators that roamed the African landscape. Aurorin tugenensis, living about 6 million years ago, provides more evidence of early bipedalism. Fossil remains of this hominin include femur bones that show adaptations for upright walking. Yet Aurorin also possessed features suited for climbing trees, suggesting these early hominins hadn't completely left their arboreal lifestyle behind. They lived in a world of transition, comfortable both in the trees and on the ground, adapting to an environment that was itself in flux. The climate continued to fluctuate, forests expanded and contracted, and our ancestors had to be versatile to survive. Ardipithecus ramidus, who lived around 4.4 million years ago, is known from a remarkably complete skeleton nicknamed Ardi. This discovery revolutionized our understanding of early human evolution. Ardi walked upright, but did so with a gait quite different from modern humans. She had opposable big toes, useful for grasping branches, indicating she still spent significant time in trees. Her teeth were unlike those of modern apes, suggesting a diet and social structure that had already begun to diverge from our common ancestor. Artie's world was one of woodland habitats, where patches of forest mingled with more open areas, creating a mosaic environment that rewarded flexibility and adaptability. The Australopithecines emerged around 4 million years ago and would dominate the human family tree for the next 2 million years. These creatures were remarkable bridges between the apes and humans, combining primitive and advanced features in fascinating ways. The most famous Australopithecus afarensis is Lucy, whose partial skeleton was discovered in Ethiopia in 1974. Lucy lived about 3.2 million years ago and stood just over 3.5 feet tall. Her species showed clear adaptations for bipedalism, with a pelvis, leg bones, and feet designed for walking upright. Yet they also retained long, curved fingers and toes, suggesting they still climbed trees, perhaps to sleep safely at night or to escape predators. Living in small groups, Australopithecines traversed the African landscape in search of food. Their diet consisted primarily of fruits, leaves, seeds, and probably some insects and small animals. They used no tools that we know of, relying instead on their hands and teeth to access food. Their brains were still quite small, about the size of a modern chimpanzee's brain, roughly 400 to 500 cubic centimeters. But within these small brains, the seeds of greater intelligence were already present. The social bonds they formed, the cooperation required to survive in a dangerous environment, the memory needed to recall where food could be found in different seasons. All of these were building the foundation for the more complex cognition that would follow. Picture yourself walking alongside these ancient ancestors through the African savanna. The sun is setting, painting the sky in brilliant shades of orange and red. A warm breeze carries the scent of grass and distant water. You watch as a group of Australopithecines moves through the landscape, their movements purposeful yet unhurried. A mother carries her infant, its tiny hands clutching her fur. Older juveniles play nearby, their games teaching them the skills they'll need to survive. The adults remain watchful, alert to any signs of danger. In the distance, a herd of ancient elephants moves across the plains, while predators lurk in the lengthening shadows. This was a world both beautiful and perilous, where every day was a test of survival. Around 2.8 million years ago, the climate became cooler and drier, and grasslands expanded at the expense of forests. This environmental change created new pressures and opportunities. It was during this period that we see the first evidence of stone tools, marking the beginning of the Paleolithic or Old Stone Age. These earliest tools, known as Alduin tools after the Olduvai Gorge in Tanzania, where they were first discovered, were simple but effective. They consisted of rocks that had been struck to create sharp edges, useful for cutting meat, scraping hides, and breaking open bones to access the nutritious marrow inside. The creation of these tools represents a cognitive leap. It requires the ability to recognize that a rock, with modification, could become something more useful. It requires planning, as suitable rocks had to be sought out and carried to where they might be needed. It requires teaching, as the technique for making these tools had to be passed from one generation to the next. The development of tool use went hand in hand with changes in diet. With tools, our ancestors could more efficiently process a wider variety of foods, including meat from large animals. This dietary shift had profound implications for our evolution. The genus Homo emerged around 2.4 million years ago, representing a new chapter in human evolution. Homo habilis, whose name means handy man, was among the first members of our genus. With a brain size of about 600 to 800 cubic centimeters, notably larger than the Australopithecines, Homo habilis showed increased cognitive abilities. They were the likely makers of those Alduin tools, and they may have been the first hominins to build simple shelters. Their teeth were smaller than those of Australopithecines, adapted to a diet that included more meat and less tough plant material. As you rest peacefully, let your mind drift to these ancient toolmakers. Imagine the concentration required to strike one rock against another just right, the satisfaction when a sharp flake breaks off, creating a cutting edge. Think of the knowledge being shared, an older individual showing a younger one how to select the right type of rock, how to hold it, where to strike. This transfer of knowledge across generations is culture in its earliest form, the beginning of humanity's greatest strength. Our ability to learn from those who came before us and build upon their discoveries. Homo erectus appeared around 1.9 million years ago and would become one of the most successful human species, surviving for more than 1.5 million years. These early humans were notably taller than their predecessors, with a body structure very similar to modern humans. They stood about 5 to 6 feet tall, with long legs adapted for efficient walking and running across open terrain. Their brain size ranged from around 800 to 1100 cubic centimeters, a significant increase that reflected growing cognitive abilities. Homo erectus was a pioneer in many ways. They were likely the first hominins to use fire, a discovery that transformed human life. Fire provided warmth on cold nights, protection from predators, light in the darkness, and a means of cooking food. Cooking made many foods easier to digest and unlocked more nutrients, further supporting brain growth and development. Gathering around a fire also created opportunities for social bonding, for sharing stories and knowledge, for strengthening the ties that held groups together. Imagine the flickering flames casting dancing shadows, the crackle of burning wood, the warmth radiating outward, and the sense of safety it provided in a dangerous world. These remarkable humans were also the first to leave Africa, spreading into Asia and Europe. Fossil evidence shows that Homo erectus reached as far as Java in Southeast Asia and Georgia in the Caucasus by about 1.8 million years ago. This migration represented an extraordinary achievement. It required adapting to new environments, new climates, new plants and animals, new challenges. The Homo erectus who walked across Arabia and into Asia faced landscapes and conditions their ancestors had never encountered. Yet they survived and thrived, demonstrating the adaptability that has always been humanity's hallmark. Homo erectus also developed more sophisticated tools. They created the Acheulean hand axe, a teardrop-shaped tool that was more refined and symmetrical than earlier stone implements. Creating these hand axes required planning, a clear mental image of the desired end product, and the skill to bring that image into reality. The fact that these tools remained largely unchanged for over 1 million years, found across Africa, Europe, and Asia, suggests the existence of cultural traditions that were passed down through countless generations. There was a right way to make a hand axe, and this knowledge was preserved and transmitted across time and space. Let yourself drift deeper into relaxation as we journey forward through time. Around 800,000 years ago, in what is now Spain, we find evidence of Homo antecessor. These humans hunted large animals, used fire, and lived in organized groups. Fossil evidence suggests they may have practiced cannibalism, though whether for nutritional, ritual, or other reasons remains unclear. The human story has never been simple or wholly peaceful. Our ancestors faced desperate times, made difficult choices, and sometimes did things we find disturbing today. Yet they survived, and their survival enabled our existence. Homo heidelbergensis emerged around 700,000 years ago and is thought to be the ancestor of both Neanderthals and modern humans. These were robust, powerful humans with brains approaching the size of modern human brains, averaging around 1,200 cubic centimeters. They hunted large game using wooden spears, and they almost certainly had some form of language or advanced communication. The coordination required for hunting large, dangerous animals like ancient elephants or wild horses demands the ability to plan, to assign roles, to work together seamlessly. This level of cooperation suggests sophisticated social structures and communication abilities. The Neanderthals evolved in Europe and Western Asia around 400,000 years ago, adapting to the cold climates of the Ice Age. With their stocky build, large noses, and prominent brow ridges, Neanderthals were supremely adapted to cold environments. Their bodies were compact, reducing heat loss, and their large nasal cavities helped warm and humidify cold air before it reached their lungs. Their brains were actually slightly larger on average than those of modern humans, though shaped differently, being longer and lower rather than the tall, rounded shape of our skulls. Neanderthals were far from the brutish, primitive creatures once imagined. They were skilled hunters who made sophisticated tools, including composite tools with wooden handles and stone points secured with pitch. They controlled fire expertly and lived in shelters, some natural caves, others constructed from mammoth bones and hides. They cared for their sick and injured, as evidenced by skeletons showing healed fractures and individuals who survived years despite debilitating injuries. This caregiving behavior reveals compassion, social bonds, and a recognition of the value of every group member. Neanderthals buried their dead, sometimes with what appear to be grave goods, suggesting they may have had beliefs about an afterlife or at least the desire to honor their deceased. They created the oldest known musical instrument, a flute carved from a cave bare bone. They used pigments like red ochre, possibly for body decoration or symbolic purposes. The more we learn about Neanderthals, the more we recognize them as fully human in their emotions, their intelligence, and their culture. They were not our ancestors but our cousins, a different branch of the human family tree that flourished for hundreds of thousands of years before disappearing around 40,000 years ago. Our own species, Homo sapiens, evolved in Africa around 300,000 years ago. The oldest known fossils of anatomically modern humans come from Jebel Irhoud in Morocco, dated to about 315,000 years ago. These early Homo sapiens had the essential skeletal features we see in humans today: a high, rounded skull, a flat face without heavy brow ridges, a prominent chin, and a gracile skeleton. But the evolution of modern human behavior took longer than the evolution of modern anatomy. For tens of thousands of years, early Homo sapiens in Africa lived much like other human species, making similar tools, following similar lifestyles. Around 70,000 years ago, something changed. Archaeologists call it the Great Leap Forward or the Upper Paleolithic Revolution. Suddenly, we see an explosion of innovation and creativity. More sophisticated tools appear, made from bone, antler, and ivory as well as stone. Art emerges, with cave paintings, carved figurines, and decorated objects. Jewelry is created from shells and beads. Long-distance trade networks develop, with materials being transported hundreds of miles from their sources. Ritual and symbolic behavior becomes evident in elaborate burials and the construction of structures that seem to serve ceremonial rather than practical purposes. What triggered this change? Some scientists believe a genetic mutation enhanced language abilities, allowing more complex communication and the more efficient transfer of knowledge. Others suggest that population pressures or environmental challenges forced innovation. Whatever the cause, this period marked the beginning of the behavioral modernity that characterizes our species. We became not just physically modern but cognitively and culturally modern, with the full capacity for abstract thought, symbolic expression, and cumulative culture that defines us today. Between 70,000 and 50,000 years ago, groups of Homo sapiens began leaving Africa, following coastal routes into the Middle East and beyond. These migrations would eventually carry humanity to every habitable continent. The first wave moved along the coast of the Arabian Peninsula and into South Asia, reaching Australia by around 65,000 years ago. The journey to Australia required crossing significant stretches of open water, evidence that these early humans had developed sophisticated watercraft and navigation skills. Imagine the courage required to set out across the ocean, not knowing what lay beyond the horizon, trusting in your knowledge of the stars, the currents, the winds. Another wave of migration moved north into Europe around 45,000 years ago, where Homo sapiens encountered the Neanderthals. For several thousand years, these two human species coexisted, occupying overlapping territories and in some cases interbreeding. Today, most people of European and Asian descent carry between 1 and 4% Neanderthal DNA in their genomes, evidence of this ancient mixing. The Neanderthal genes we carry influence various traits, from skin and hair color to immune system function to susceptibility to certain diseases. Our extinct cousins live on in us, their genetic legacy woven into our own. The spread of Homo sapiens across the globe demonstrates our species' remarkable adaptability. We learned to survive in tropical rainforests and Arctic tundra, in deserts and mountains, on small islands and vast continents. Each new environment required new solutions, new technologies, new knowledge. Those who settled in the far north had to learn to hunt seals and polar bears, to build insulated shelters from snow and ice, to cope with months of darkness. Those in the tropics developed ways to deal with heat, humidity, and diseases unknown in cooler climates. Those on islands became expert seafarers, navigating vast stretches of ocean using only the stars, waves, and birds as guides. As you relax even more deeply, picture the diversity of human cultures that emerged across the world. In Europe, hunters followed great herds of reindeer and horses across the tundra, painting stunning images of animals on cave walls by the flickering light of torches. In the Middle East, people began to experiment with cultivating wild grains, taking the first steps toward agriculture. In Australia, Aboriginal peoples developed an intricate understanding of the land, managing it through controlled burning and maintaining oral traditions that preserved knowledge across tens of thousands of years. On the steppes of Central Asia, mobile groups moved with their animals, their entire lives adapted to the rhythm of migration. Each culture was a unique solution to the challenges of survival, each a testament to human ingenuity and resilience. The last ice age reached its peak around 20,000 years ago, when ice sheets covered much of northern Europe, Asia, and North America. Sea levels were much lower than today because so much water was locked up in glaciers, and land bridges connected regions now separated by ocean. One such land bridge, called Beringia, connected Siberia to Alaska, and it was across this bridge that humans first entered the Americas, likely between 15,000 and 20,000 years ago. These pioneers spread rapidly through the continents, reaching the southern tip of South America within just a few thousand years. They hunted mammoths, giant sloths, and other megafauna, many of which would go extinct, whether due to hunting pressure, climate change, or a combination of both. The end of the Ice Age around 11,700 years ago brought dramatic changes. The climate warmed, ice sheets retreated, sea levels rose, and ecosystems shifted. Many large animals went extinct, and humans had to adapt to new conditions. It was during this period that agriculture independently developed in several regions around the world. In the Fertile Crescent of the Middle East, people began cultivating wheat and barley and domesticating sheep and goats. In China, millet and rice were cultivated. In Mesoamerica, corn, beans, and squash became staples. In the Andes, potatoes and quinoa were domesticated. In New Guinea, people grew taro and yams. The shift from hunting and gathering to agriculture was gradual and not always a clear improvement in quality of life. Early farmers worked harder than hunter-gatherers, had less varied diets, and suffered from more diseases due to living in close proximity to both animals and other people. Yet agriculture had one crucial advantage. It could support much larger populations. A piece of land that might support one hunter-gatherer family could support 10 or more farming families. As populations grew, villages became towns, towns became cities, and the first civilizations emerged. With cities came writing, mathematics, astronomy, specialized crafts, monumental architecture, and increasingly complex social hierarchies. Let your mind wander through these ancient civilizations. In Mesopotamia, the Sumerians built great ziggurats and developed cuneiform writing, recording everything from tax records to epic poems. In Egypt, pharaohs constructed massive pyramids as tombs, organizing the labor of thousands to create monuments that would stand for millennia. In the Indus Valley, planned cities with sophisticated drainage systems housed tens of thousands of people. In China, dynasties rose and fell, each leaving its mark on history. In the Americas, civilizations like the Olmec, Maya, and later, the Inca built impressive cities and monuments without the benefit of metal tools or wheeled vehicles. Testaments to human ingenuity and determination. The biological evolution of our species has continued, even as culture has become an increasingly dominant force in shaping human life. Over the past 10,000 years, we have evolved lighter skin in northern latitudes, an adaptation to produce sufficient vitamin D with less sunlight. We have evolved the ability to digest milk as adults, a trait that became advantageous with the domestication of dairy animals. We have evolved resistance to certain diseases, like malaria in regions where it is endemic. These changes remind us that evolution is an ongoing process, not something that stopped in the past. Human brain size has actually decreased slightly over the past 20,000 years, from an average of around 1,500 cubic centimeters to about 1,350 today. This doesn't mean we've become less intelligent. Rather, it may reflect changes in how we use our brains. We rely more on accumulated cultural knowledge and less on individual knowledge. We live in more complex social groups that may select for different cognitive skills. Our brains have become more efficient, able to do more with less. Throughout our evolutionary journey, several key themes emerge. Adaptation has been constant, with our ancestors changing in response to environmental challenges and opportunities. Innovation has driven progress, from the first stone tools to the complex technologies we use today. Cooperation has been essential, enabling us to achieve things no individual could accomplish alone. And learning, the ability to acquire knowledge and pass it on to others, has been perhaps our greatest strength. Unlike other animals who must rely primarily on instinct and individual learning, we build upon the accumulated wisdom of countless generations. Consider the remarkable changes in our anatomy that made us human. Our upright posture freed our hands for tool use and carrying. Our hands themselves, with their long, opposable thumbs and sensitive fingertips, became precision instruments capable of the finest manipulation. Our pelvis changed to support upright walking, but also had to accommodate the birth of infants with increasingly large heads. A challenging evolutionary compromise that makes human birth more difficult and dangerous than in other primates. Our vocal tract was reconfigured to allow the production of a wide range of sounds, essential for complex language. Our brains tripled in size over the course of human evolution, from about 400 cubic centimeters in Australopithecus to about 1,350 cubic centimeters in modern humans. This increase in brain size, particularly in areas associated with planning, abstract thinking, language, and social cognition, enabled the development of our remarkable cognitive abilities. But a larger brain came with costs. It requires enormous amounts of energy, consuming about 20% of the body's calories despite comprising only about 2% of body weight. It required changes in diet to provide the necessary nutrients. And it required a longer childhood to give the brain time to develop and to learn the complex skills needed to function in human society. The evolution of language was crucial to our success, though the exact timeline and mechanisms remain debated. Language allows us to share detailed information about the world, to discuss things that are not immediately present, to plan for the future, to convey abstract concepts, and to build complex social relationships. It enables cumulative culture, the ability to build on the knowledge of previous generations, which has allowed human knowledge and technology to grow exponentially. Some scientists believe language evolved gradually, starting with simple calls and gestures that became increasingly complex over hundreds of thousands of years. Others suggest a relatively sudden emergence, perhaps linked to genetic mutations that rewired the brain for language. Social evolution has been as important as biological evolution in making us who we are. Early human groups were small, perhaps 20 to 50 individuals, consisting of related families. These groups provided mutual support, shared resources, and protected each other from predators and rival groups. As groups grew larger, new mechanisms were needed to maintain cohesion. Language helped, allowing people to maintain relationships and share information efficiently. Shared beliefs, rituals, and symbols created common identities and purposes. Rules and norms governed behavior, enforced by social pressure and eventually formal institutions. The ability to cooperate in large groups of mostly unrelated individuals is one of humanity's unique characteristics, enabling us to build complex societies and accomplish extraordinary things. The evolution of human emotions and psychology shaped our social behavior. We developed strong attachments to our children, ensuring they received the prolonged care they needed to survive. We felt empathy, allowing us to understand and respond to the needs of others. We experienced jealousy, protecting our relationships and resources. We felt pride and shame, emotions that helped maintain our standing in the group. We sought fairness and punished cheaters, maintaining cooperation in the face of temptations to defect. These emotional responses, shaped by millions of years of evolution, continue to influence our behavior today, even in the very different world we now inhabit. Sexual selection has also played a role in human evolution. Characteristics that made individuals more attractive to potential mates became more common. Preferences for certain physical features, personality traits, or abilities could drive evolutionary change. The relative lack of sexual dimorphism in humans compared to many other primates suggests that both males and females have been choosy in selecting mates. Long-term pair bonding, while not universal, has been common in human societies, with both parents investing in the care of offspring. This biparental care allowed human children to receive more resources and attention, supporting their long period of development. As you sink into a state of peaceful rest, think about the deep history encoded in your own body. The structure of your spine speaks of ancestors who learned to walk upright. Your hands bear the legacy of toolmakers. Your large brain is the product of millions of years of selection for intelligence and social skills. Your capacity for language connects you to every human who has ever lived, for we all share the same basic linguistic abilities. Even your DNA carries stories of the past, with segments inherited from ancient ancestors, mixed and recombined over countless generations. The study of ancient DNA has revolutionized our understanding of human evolution and migration. By extracting and sequencing DNA from fossils, scientists can trace lineages, identify when populations diverged, and even discover previously unknown human species. In 2010, DNA from a finger bone found in Denisova Cave in Siberia revealed an entirely new group of ancient humans, now called Denisovans. Though we have few physical remains of these mysterious cousins, we know they existed, and we know that they interbred with Homo sapiens. People in Melanesia and Australia carry the most Denisovan DNA, up to 5% of their genome, evidence of encounters tens of thousands of years ago. These discoveries remind us that the human family tree is not a simple, straight line, but a complex branching structure with multiple species coexisting at various times. For most of human history, we were not alone. We shared the world with other types of humans, each with their own adaptations, cultures, and ways of life. The fact that only one human species, Homo sapiens, survives today is unusual. For millions of years, multiple human species existed simultaneously. Understanding why we alone survived is one of the great questions in paleoanthropology. Some suggest that Homo sapiens outcompeted other human species, being more efficient at finding food, creating tools, or adapting to changing environments. Others propose that we violently displaced them, though direct evidence of conflict is limited. Interbreeding may have absorbed small populations of other human species into the expanding population of Homo sapiens. Climate change may have played a role, with some species less able to adapt to new conditions. Most likely, the answer involves a combination of these factors, varying in importance in different regions and at different times. The evolutionary journey of humanity is not just about physical changes or the acquisition of new abilities. It's also a story of loss. We have lost the ability to produce our own vitamin C, a trait our distant ancestors had but we lost because dietary sources were abundant. We have lost most of our body hair, trading the insulation and protection it provided for better heat dissipation through sweating, advantageous for endurance running in hot climates. We have lost some of the physical strength of our ape relatives, our muscles less powerful pound for pound, a trade-off perhaps for greater endurance and fine motor control. Evolution is not about perfection, but about adaptation to specific circumstances, and adaptations that were advantageous in one context can become burdens in another. The diversity we see among human populations today is the result of tens of thousands of years of evolution in different environments. Skin color varies from the darkest browns in equatorial regions, where melanin protects against intense UV radiation, to the palest shades in northern regions, where lighter skin allows for better vitamin D production with limited sunlight. Body proportions vary, with people in hot climates tending to have longer limbs that help dissipate heat, while those in cold climates have more compact bodies that conserve warmth. These variations are superficial, affecting less than 0.1% of our DNA. The vast majority of genetic diversity exists within populations, not between them. Biologically, the concept of distinct human races has no meaningful basis. We are one species, one family, with more that unites us than divides us. The pace of cultural evolution has far outstripped biological evolution in recent millennia. The world our Stone Age ancestors knew has been transformed beyond recognition, yet our biology has changed little. We still have brains adapted for life in small groups of hunter-gatherers, emotions shaped by the challenges our ancestors faced, instincts honed over millions of years. This mismatch between our evolved biology and the modern environment can create problems. Our preference for high-calorie foods, once a survival advantage when such foods were scarce, now contributes to obesity in environments where they are abundant. Our tendency to form in-groups and out-groups, useful for cooperation and protection in small societies, can fuel prejudice and conflict in diverse, complex societies. Our stress responses, designed for dealing with immediate physical threats, can be triggered by chronic modern stresses they were not designed to handle. Yet our evolutionary heritage also provides us with remarkable gifts. Our curiosity, the drive to explore and understand the world, has led to every scientific discovery and technological innovation. Our creativity, the ability to imagine things that don't exist and bring them into being, has given us art, music, literature, and all the cultural richness of human civilization. Our compassion, the capacity to care for others and alleviate suffering, has built hospitals, schools, and charitable institutions. Our sense of justice, the desire for fairness, has driven movements for equality and human rights. These traits, shaped by evolution, are the foundation of everything good that humanity has achieved. As you continue to relax, breathing slowly and deeply, reflect on the incredible journey that has brought you into existence. Every one of your ancestors, going back millions of years, survived long enough to reproduce. They survived droughts and ice ages, predators and diseases, famines and conflicts. Each made the choices, whether conscious or not, that led to the next generation. The chain was never broken. You are the product of an unbroken line of survivors, of those who adapted, who persevered, who overcame. This resilience is part of your heritage, written in your genes and embodied in your very existence. The story of human evolution is still being written. We continue to evolve biologically, though the changes are usually too slow to be observed in a single lifetime. We evolve culturally at a rapid pace, with each generation facing new challenges and developing new solutions. We are now the first species capable of understanding our own evolution, of reading the history written in fossils and DNA, of recognizing ourselves as part of the great web of life that covers our planet. We are the first species capable of deliberately shaping our future evolution, whether through choices about our environment, our diet, our reproduction, or even, potentially, through direct modification of our genome. This knowledge brings both opportunity and responsibility. We can use our understanding of evolution to improve human health, to address genetic diseases, to better understand our behavior and psychology. But we must also proceed with wisdom and caution, recognizing the complexity of biological systems and the potential for unintended consequences. We are part of nature, products of evolution, but we are also apart from nature in our capacity to understand and shape it. Finding the right balance, honoring our evolutionary heritage while responsibly managing our future, is one of the great challenges facing humanity. Consider the ways in which modern life differs from the environment in which we evolved. For most of human history, people lived in small groups, knew everyone they interacted with, spent most of their time outdoors engaged in physical activity, ate foods they gathered or hunted themselves, experienced natural cycles of light and darkness, and had direct contact with the natural world. Today, many people live in large cities among strangers, spend most of their time indoors engaged in sedentary activities, eat processed foods produced far away. experience artificial light that disrupts natural circadian rhythms, and have limited contact with nature. These changes have occurred far too rapidly for biological evolution to keep pace, and they create novel challenges for our evolved minds and bodies. Yet humans have always been adaptable, and we continue to find ways to thrive in new conditions. We create communities and social networks that provide the sense of belonging our ancestors found in their small groups. We develop new forms of physical activity and recreation. We learn about nutrition and make informed choices about what we eat. We seek out nature in parks and wild spaces, recognizing an innate need for connection with the natural world. We are not helpless victims of modernity, but active agents capable of making choices that align our lives with our evolved needs. The future of human evolution is uncertain and full of possibilities. Climate change, technological advancement, globalization, and many other forces are shaping the world in ways our ancestors could never have imagined. How we respond to these challenges will determine the path of future evolution. Will we use technology to overcome the limitations of our biology, perhaps extending our lifespan, enhancing our cognitive abilities, or even leaving Earth to colonize other worlds? Will we modify our genes to eliminate diseases, enhance desirable traits, or adapt to new environments? Or will we choose a different path, finding ways to live sustainably on Earth, embracing our biological nature, accepting the limitations and imperfections that are part of being human? These are not just scientific or technological questions, but ethical and philosophical ones. They require us to think deeply about what it means to be human, what we value, and what kind of future we want to create. Our evolutionary history can inform these discussions, but cannot dictate the answers. We must draw on all aspects of our humanity, our reason and emotion, our science and our values, our individual perspectives and our collective wisdom to navigate the challenges ahead. As you drift toward sleep, let the story of human evolution remind you of the connection we all share. Every human being on Earth is your cousin, descended from the same ancestors, carrying the same basic genetic blueprint. The differences between us, whether of appearance, culture, language, or belief, are tiny variations on a common theme. We all feel the same basic emotions, seek the same fundamental needs, face the same existential questions. Recognizing our common humanity, our shared evolutionary heritage, can help us bridge the divisions that separate us and work together to address the challenges facing our species and our planet. The tale of human evolution is one of transformation, of simple beginnings giving rise to extraordinary complexity, of ancient apes becoming creatures capable of contemplating the universe and our place within it. It's a story of survival against incredible odds, of adaptation to changing circumstances, of innovation and creativity, of cooperation and cultural learning. It's a story that continues in each of us, as we live our lives, make our choices, and contribute to the ongoing evolution of our species. Let us explore deeper into the fascinating details of how our bodies evolved to become the remarkable machines they are today. Consider your eyes, those windows through which you perceive the world. The human eye is a marvel of evolutionary engineering, with a history stretching back hundreds of millions of years to our distant vertebrate ancestors. Our early primate ancestors developed excellent color vision, crucial for identifying ripe fruits in the forest canopy. They evolved forward-facing eyes that provided stereoscopic vision, allowing accurate depth perception essential for leaping between branches. The human eye can distinguish millions of colors, adjust to an enormous range of light conditions, and track rapid movement with remarkable precision. All of this complexity arose through countless small modifications over millions of years, each providing some survival advantage that was passed on to the next generation. Your sense of smell, though less acute than in many other mammals, carries its own evolutionary story. Our ancestors who spent more time in trees relied less on scent than their ground-dwelling relatives. And natural selection gradually reduced the proportion of our genome devoted to olfactory receptors. Yet we still have about 400 functional olfactory receptor genes, allowing us to detect thousands of different odors. The emotional power of smell, its ability to trigger vivid memories and strong feelings, speaks to its ancient importance. The olfactory bulb connects directly to the limbic system, the emotional center of the brain, a connection forged when smell was our ancestors' primary way of sensing danger, finding food, and recognizing kin. The human hand is another evolutionary masterpiece. With its opposable thumb, sensitive fingertips, and remarkable dexterity, it can perform tasks ranging from the brutally forceful to the incredibly delicate. Our ancestors' hands evolved first for grasping branches, then for manipulating objects, and eventually for making and using tools. The proportion of the brain devoted to controlling the hand is enormous, reflecting the importance of fine motor control to our species. Consider all that your hands can do: write, paint, play musical instruments, perform surgery, build structures, comfort others with a gentle touch. Each capability is the product of millions of years of evolution, refined and perfected through generation after generation. Our feet, too, tell a story of adaptation. The human foot is unique among primates, with its characteristic arch that acts as a shock absorber and spring, making bipedal walking and running efficient over long distances. Our big toe aligns with the other toes rather than sticking out to the side like a thumb, providing stability and power during the push-off phase of walking. The loss of the grasping ability that our ape relatives possess was a trade-off for better performance on the ground. Every step you take is possible because of changes that occurred in your ancestors millions of years ago, as they adapted to life in more open environments. The human spine shows clear evidence of our evolutionary journey. Its S-shaped curve is an adaptation to upright posture, distributing weight and absorbing shock as we walk and run. But this adaptation is imperfect, which is why back pain is so common in humans. The spine evolved from a horizontal support structure, like that of a bridge, to a vertical column, like that of a tower, and this transition was never entirely complete. We still experience the consequences of this evolutionary compromise, a reminder that evolution works with what exists, modifying existing structures rather than designing ideal solutions from scratch. Breathe deeply and slowly as you consider your respiratory system. The human lungs are inherited from our distant fish ancestors, who evolved primitive lungs to supplement the oxygen they could extract through gills in oxygen-poor waters. Over hundreds of millions of years, these simple sacs became the complex organs we have today, with millions of tiny air sacs called alveoli providing an enormous surface area for gas exchange. The rhythm of your breathing, the automatic rising and falling of your chest, connects you to every air-breathing animal that has ever lived. Your breath is a link across time, from ancient lungfish gasping in Devonian swamps to your ancestors sleeping under African stars to you now, gently drifting towards sleep. The human digestive system reflects our omnivorous diet and our evolutionary history. Unlike herbivores with their specialized stomachs and long intestines, designed to extract nutrients from tough plant material, or carnivores with their short digestive tracts suited for processing meat, humans have a middle ground system capable of handling a wide variety of foods. Our stomach acid is stronger than that of many herbivores, able to break down protein and kill bacteria in meat. Yet we also produce enzymes that break down carbohydrates, and we harbor billions of beneficial bacteria in our intestines that help us digest plant fibers. This flexibility reflects the varied diets of our ancestors, who ate whatever was available, adapting their food choices to the seasons and the environment. The loss of our appendix's original function is an interesting evolutionary note. In our herbivorous ancestors, the appendix was part of a larger cecum that helped digest cellulose from plants. As our diet shifted to include more meat and our cecum shrank, the appendix became vestigial, a remnant of our past with no clear current function. Yet it hasn't disappeared entirely, perhaps because it serves as a reservoir for beneficial gut bacteria, or perhaps simply because its presence causes no significant harm. And evolution has no reason to eliminate it. Such remnants of our evolutionary past are scattered throughout our bodies, silent witnesses to the long journey that created us. Consider the fascinating evolution of human teeth. Our ancestors had large, powerful jaws and teeth, adapted for grinding tough plant material. As our diet shifted to include more meat and cooked foods, which are easier to chew, our jaws became smaller and our teeth more gracile. This reduction in jaw size creates problems in modern humans, as there is often not enough room for all our teeth, leading to impacted wisdom teeth that must be removed. Our dental anatomy reflects adaptations to diets from millions of years ago, and changes in what we eat over the past 10,000 years have occurred too recently for evolution to fully catch up. The evolution of human birth is marked by tension between two competing evolutionary pressures. The shift to bipedalism narrowed the pelvis, making the birth canal smaller. At the same time, selection for larger brains meant babies' heads grew bigger. The result is that human birth is unusually difficult and dangerous compared to other primates. Human infants are born at an earlier stage of development than the infants of other apes, essentially helpless, unable to cling to their mothers or move independently. This extended period of infant helplessness has profound implications, requiring intensive parental care and creating strong bonds between parents and children. It has also selected for social structures where mothers receive help from others in caring for infants, a feature that may have been crucial in the evolution of human cooperation and society. Human pregnancy itself is a biological marvel shaped by evolution. The placenta, the organ that connects mother and fetus, is more invasive in humans than in most other mammals. It burrows deep into the uterine wall, giving the fetus greater access to the mother's blood supply. This invasiveness is thought to reflect an evolutionary arms race between maternal and fetal genes, with the fetus evolving to extract more resources and the mother evolving to limit what she provides. The nausea of early pregnancy may be an adaptation to protect the developing fetus from toxins in food. The cravings and aversions pregnant women experience may guide them toward beneficial nutrients and away from potentially harmful substances. Every aspect of pregnancy, from conception to birth, bears the marks of millions of years of evolutionary fine-tuning. The development of a human from a single fertilized cell into a complex organism recapitulates, in a sense, our evolutionary history. In the earliest stages, a human embryo resembles the embryos of other vertebrates, with structures like gill slits and a tail that later disappear or transform into other structures. As development proceeds, the embryo becomes more distinctly mammalian, then primate, then specifically human. This pattern, where development mirrors evolution, is not perfect or absolute, but it reflects the fact that evolution works by modifying existing developmental programs, adding new steps while often retaining earlier stages. You began your life as a single cell, went through stages resembling a fish, a reptile, an early mammal, and finally emerged as a human infant. Retracing in months, a journey that took hundreds of even more deeply. Let your awareness turn to the human brain, the most complex object we know of in the universe. The brain you possess is the product of an extraordinary evolutionary journey. The basic structure, with its brain stem, cerebellum, and cerebrum, is shared with other vertebrates, each part layered on top of older structures in the course of evolution. The brainstem, often called the reptilian brain, controls basic functions like breathing, heart rate, and arousal. The limbic system, which includes structures like the amygdala and hippocampus, is involved in emotion and memory and is shared with other mammals. The neocortex, the wrinkled outer layer of the brain, is greatly expanded in humans and is responsible for higher cognitive functions like language, abstract thought, planning, and self-awareness. The human brain's evolution involved not just an increase in overall size, but changes in structure and organization. The prefrontal cortex, located behind the forehead, is particularly well developed in humans. This area is involved in executive functions like planning, decision-making, impulse control, and social behavior. Damage to the prefrontal cortex can dramatically change personality and behavior, highlighting its importance in making us who we are. The expansion of the prefrontal cortex in human evolution may be one of the key changes that enabled our distinctive cognitive abilities and complex social behavior. Language areas in the brain, particularly Broca's area and Wernicke's area, show specialization for linguistic processing. Broca's area, located in the frontal lobe, is involved in speech production, while Wernicke's area in the temporal lobe is involved in language comprehension. The existence of these specialized areas suggests that language has been important in human evolution, long enough for dedicated neural machinery to evolve. Studies of other primates show precursors to these areas, hinting at the origins of language in the communication systems of our ancestors. But the full development of these regions and their integration with other cognitive systems appears to be unique to humans. The connection between the two hemispheres of the brain, the corpus callosum, allows the left and right sides to communicate and coordinate. The left hemisphere typically specializes in language and analytical thinking, while the right hemisphere excels at spatial processing and recognizing faces and emotions. This lateralization of function, where different sides of the brain specialize in different tasks, is more pronounced in humans than in other primates. The evolutionary advantage of having specialized hemispheres may relate to efficiency, allowing more complex processing in a finite amount of neural tissue. Though the reasons for this pattern are still debated. Human memory systems are the product of evolution's need to balance several competing demands. We need to remember important information, like where food can be found or which individuals are trustworthy, but we also need to forget irrelevant details that would clutter our minds. We need to recall past experiences accurately, but we also need to extract general principles that can guide future behavior. The result is a memory system that is not a perfect recorder but a selective, reconstructive process. We remember events not as exact recordings but as stories we tell ourselves, shaped by our emotions, our current knowledge, and our expectations. This may seem like a flaw, but it's actually an adaptive feature, allowing us to focus on what's meaningful and apply lessons from the past flexibly to new situations. Sleep, the state you are now entering, is itself an evolutionary adaptation. All mammals sleep, as do birds and probably many other animals. Sleep appears to serve multiple functions: consolidating memories, clearing metabolic waste from the brain, repairing cellular damage, and regulating hormones and immune function. The fact that animals are willing to spend a third of their lives in a state of unconsciousness, vulnerable to predators, and unable to forage or reproduce, speaks to how essential sleep must be. Our ancestors slept, as you sleep now, allowing their brains to process the day's experiences and prepare for the challenges of tomorrow. The dreams you may experience during sleep are thought by some researchers to be a way the brain explores scenarios and solves problems, a kind of mental simulation that enhances learning and creativity. Human skin is a remarkable organ with its own evolutionary story. Our nearly hairless skin sets us apart from other primates and is thought to be an adaptation to help us cool down during the heat of the day in the African savanna. Humans are exceptional long-distance runners, and our ability to sweat copiously, combined with minimal body hair, allows us to dissipate heat effectively. This was a significant advantage for our ancestors who hunted by persistence, chasing prey animals until they overheated and collapsed. Our prey might be faster in a sprint, but we could outlast them in the long run, our superior cooling system allowing us to continue when they had to stop and rest. The variation in human skin color is one of the most visible ways in which populations have adapted to different environments. Melanin, the pigment that gives skin its color, protects against UV radiation, which can damage DNA and cause skin cancer. In equatorial regions with intense sunlight, dark skin with lots of melanin provides crucial protection. In regions far from the equator, where sunlight is less intense, lighter skin allows for better production of vitamin D, which is synthesized in the skin in response to UV radiation. Over thousands of years, populations evolved skin tones suited to their local UV environments. This adaptation is relatively recent in evolutionary terms, occurring after humans spread across the globe, which is why it is one of the few visible ways in which human populations differ. Hair, though greatly reduced on most of the human body, remains on our heads, where it protects the scalp from sun exposure. The evolution of hair texture is another adaptation to climate, with tightly coiled hair providing excellent protection from the sun while creating insulating air pockets that help cool the scalp. Different populations evolved different hair textures suited to their environments. Meanwhile, facial and body hair serves different functions, with facial hair possibly playing a role in sexual selection or social signaling, though the evolutionary reasons for its retention are still debated. The human immune system is a complex defense network that evolved over millions of years to protect against pathogens. It includes both innate immunity, which provides immediate but nonspecific defense, and adaptive immunity, which learns to recognize specific pathogens and mounts targeted responses. The adaptive immune system, with its ability to remember previous infections and respond more quickly to future encounters with the same pathogen, is a remarkable example of biological learning. Each time you fight off an infection, your immune system retains a memory of that pathogen, allowing you to resist reinfection. This is the principle behind vaccination, where we harness the immune system's natural learning ability to protect against diseases without having to suffer through the illness itself. Human populations have evolved various genetic adaptations to resist specific diseases. Sickle cell trait, which provides resistance to malaria, is common in populations from regions where malaria is endemic. Similarly, certain versions of genes related to immune function are more common in populations that historically faced specific diseases. The major histocompatibility complex, or MHC, a set of genes involved in immune function, is one of the most variable regions of the human genome. Likely because diversity in these genes helps populations resist a wider range of pathogens. Interestingly, humans show preferences for mates with different MHC genes than their own, possibly detected through scent, which would result in offspring with greater immune diversity and resistance to disease. The evolution of human diet and metabolism has shaped our nutritional needs and our susceptibility to modern diseases. For most of human history, food was scarce and unpredictable. Our ancestors, who could efficiently store energy as fat during times of abundance, survived better during times of scarcity. This thrifty genotype served our ancestors well, but can lead to obesity and related health problems in modern environments where high-calorie foods are constantly available. Similarly, our taste preferences evolved to lead us toward nutritious foods, with sweetness indicating ripe fruits and energy-rich carbohydrates, saltiness indicating necessary minerals, and bitterness warning of potential toxins. In the modern food environment, these preferences are exploited by processed foods engineered to be hyperpalatable, potentially leading to overconsumption and health problems. The ability to digest lactose, the sugar in milk, beyond infancy is a recent evolutionary adaptation, emerging only in the past few thousand years in populations that practice dairy farming. Normally, the gene that produces lactase, the enzyme that digests lactose, switches off after weaning. But in populations that kept dairy animals and drank their milk, mutations that kept the lactase gene active into adulthood provided a survival advantage, allowing individuals to access a valuable source of nutrition. This gene spread rapidly through these populations, becoming one of the clearest examples of recent human evolution. Today, lactose tolerance is common in people of European descent and in some African and Middle Eastern populations with a history of dairy farming. While most of the world's population remains lactose intolerant. Human longevity is another fascinating aspect of our evolution. Compared to other primates, humans live a remarkably long time, with many people living for decades after their reproductive years end. This extended post-reproductive lifespan is unusual in nature and may be an adaptation related to the grandmother hypothesis. This hypothesis suggests that older women who no longer bear children themselves can increase their genetic legacy by helping care for their grandchildren, improving the survival and success of the next generation. The presence of grandmothers and other older adults who can share knowledge, provide care, and contribute to the group may have been crucial in human evolution, allowing the transmission of complex cultural information across generations. The human life cycle itself, with its extended childhood and adolescence, is shaped by evolution. Human children remain dependent on adults for longer than the young of other species, a period during which their large brains grow, and they learn the complex skills needed to function in human society. Adolescence, the period between childhood and full adulthood, is marked by physical maturation and dramatic changes in social behavior. The teenage brain undergoes significant reorganization, with increased sensitivity to social rewards and peer influence. This may be an adaptation that motivates adolescents to leave their family groups and integrate into the broader social world, an important transition in many human societies. The sometimes risky and impulsive behavior of teenagers, often frustrating to adults, may have evolved to encourage exploration and the development of independence. As you drift deeper into peaceful rest, consider the evolution of human emotions. Our emotional responses, from joy to fear to anger to love, are the products of millions of years of evolution, shaped by the challenges our ancestors faced. Fear evolved to help us avoid danger, with quick, automatic responses to threats that could mean the difference between life and death. Our fear of snakes and spiders, common even in people who have never encountered dangerous versions of these creatures, may be inherited from ancestors for whom such animals posed real threats. Disgust evolved to help us avoid contamination and disease, with strong reactions to things like rotting food, waste, and signs of illness in others. Happiness and pleasure evolved to reward behaviors that enhanced survival and reproduction, encouraging us to seek food, form social bonds, and engage in activities beneficial to ourselves and our genes. Love, in its various forms, has played a crucial role in human evolution. Parental love, the deep bond between parent and child, motivates the intensive care that human infants require. Romantic love, with its intense passion and desire for commitment, may have evolved to keep partners together long enough to raise children through their vulnerable early years. The love between friends and community members strengthens social bonds and encourages cooperation. These emotions are not mere byproducts of evolution, but adaptations that helped our ancestors survive and reproduce. The capacity to love deeply, to care about others as much as or more than ourselves, is one of the defining features of humanity, shaped by millions of years of social evolution. Human morality, our sense of right and wrong, also has evolutionary roots. Behaviors like altruism, fairness, and reciprocity can be found not only in humans but also in other social primates, and even in some non-primate species. These moral intuitions may have evolved because they promoted cooperation and group cohesion, which were essential for survival. Groups whose members cooperated, shared resources, and punished cheaters were more successful than groups where everyone acted purely selfishly. Over time, natural selection favored individuals with strong moral intuitions and the emotions that enforce them, like guilt when we violate moral norms and anger when others do. While culture certainly shapes the specific content of moral codes, the basic moral emotions and intuitions appear to be universal, suggesting deep evolutionary roots. The human sense of self, our subjective awareness of being an individual with a continuous identity over time, is one of the great mysteries of neuroscience and philosophy. This self-awareness, which includes the ability to reflect on our own thoughts and mental states, appears to be unique to humans, or at least uniquely developed in our species. The evolution of self-awareness may be linked to our social nature. To navigate complex social relationships, it helps to be able to think about what others are thinking, to predict their behavior, to understand their motivations. This ability, called theory of mind, requires a sense of self as distinct from others. Children develop theory of mind abilities around the age of 4, a crucial milestone in their social development. The neural basis of self-awareness involves multiple brain regions, including the prefrontal cortex and areas involved in social cognition, suggesting it emerged from the elaboration of social cognitive abilities in our evolutionary history. Human music and dance are universal features of culture, found in every society, suggesting they may have deep evolutionary significance. Music may have emerged from the emotional vocalizations of our ancestors, elaborated and formalized through cultural evolution. It has the power to coordinate groups, creating shared emotional states and strengthening social bonds. Dance, too, is a form of coordinated movement that brings people together. Some researchers suggest that music and dance may have been important in human evolution, perhaps in courtship rituals, in group bonding, or in religious and spiritual practices. The fact that music and rhythm activate pleasure centers in the brain, releasing dopamine and creating feelings of euphoria, suggests that we are neurologically wired to find these activities rewarding. Human laughter is another universal behavior with evolutionary roots. Laughter appears to have evolved from the play vocalizations of our primate ancestors, serving as a social signal that an activity is playful and non-threatening. Laughter promotes bonding, diffuses tension, and creates positive social interactions. The contagious nature of laughter, the way hearing others laugh makes us want to laugh too, reinforces its role in social cohesion. Humor, the cognitive ability to appreciate and create situations that provoke laughter, may be uniquely human, though its evolution and adaptive value are still debated. The ability to laugh at ourselves, to find humor in difficult situations, may be a psychological mechanism that helps us cope with stress and adversity. The human tendency to create and appreciate art appears to be universal, found in cultures throughout history and across the globe. Cave paintings tens of thousands of years old show that our ancestors created art, depicting animals, human figures, and abstract patterns. This artistic impulse may have served multiple functions: as a form of communication, as a way of representing and understanding the world, as a means of social bonding, or as expressions of spiritual or religious beliefs. The aesthetic sense, the ability to perceive and appreciate beauty, is thought by some to be an evolutionary adaptation, perhaps originally linked to recognizing healthy mates, nutritious foods, or beneficial environments, but elaborated through cultural evolution into the rich artistic traditions we see today. Human spirituality and religion, the belief in supernatural entities and forces, is another near-universal feature of human cultures. While the specific content of religious beliefs varies enormously, the tendency to develop such beliefs appears to be a common feature of human psychology. Some evolutionary psychologists suggest that religious beliefs and practices may have provided adaptive advantages, promoting cooperation within groups, providing comfort in the face of uncertainty and mortality, or offering explanations for natural phenomena. Others argue that religion is a byproduct of cognitive adaptations that evolved for other purposes, such as the tendency to detect agency in the world, the capacity for imagination, or the need to find meaning and purpose. Whatever its origins, religion has been a powerful force in human history, shaping societies, motivating behavior, and providing frameworks for understanding existence. The evolution of human warfare and violence is a sobering aspect of our history. Evidence of violent conflict, including weapons and fortifications, appears in the archaeological record, and violence has been documented in virtually all human societies. At the same time, humans are also capable of remarkable altruism, cooperation, and peace. This duality suggests that human nature includes both aggressive and cooperative tendencies, with the expression of these tendencies depending on circumstances. Evolutionary theories of violence suggest that aggression may have been adaptive in certain contexts, such as competition for resources or mates, while cooperation was adaptive in others, such as hunting large game or defending against external threats. Understanding the evolutionary roots of both our aggressive and cooperative tendencies may help us create social conditions that promote peace and reduce violence. The role of women in human evolution has often been underestimated. In early theories, human evolution was portrayed as driven primarily by male hunting, with women playing passive roles. More recent research has highlighted the crucial contributions of women to human survival and evolution. Gathering, primarily done by women in most hunter-gatherer societies, typically provided the majority of calories, making it essential to survival. Women's knowledge of plants, their seasonal availability, and their preparation was vital. The tools associated with gathering, such as digging sticks and baskets, were important innovations, even if they are less visible in the archaeological record than the stone tools associated with hunting. Women's social networks, their role in childcare and in teaching the next generation, their potential innovations in technology and culture, all contributed to human evolution and success. Human cooperation extends beyond kin and close associates to include large groups of unrelated individuals, a feature that sets us apart from other primates. We cooperate in groups of thousands or millions, forming nations, corporations, religions, and other large-scale organizations. This ability rests on our capacity for shared beliefs and collective identities. We can imagine ourselves as part of a group, sharing common goals and values with people we've never met. This capacity for large-scale cooperation has allowed humans to accomplish extraordinary things. From building cities and monuments to conducting scientific research and creating systems of law and governance. It has also enabled warfare and oppression on massive scales, showing that cooperation, while powerful, can be directed toward both beneficial and harmful ends. Language, perhaps humanity's most distinctive trait, has enabled all of these complex cultural achievements. Unlike other animal communication systems, human language is open-ended, allowing us to create an infinite number of sentences to express new thoughts. We can talk about things that are not present, that happened in the past or might happen in the future, that are abstract or hypothetical. This displacement, the ability to refer to things beyond the immediate here and now, is crucial for planning, for teaching, for telling stories, for building shared understandings of the world. The combinatorial nature of language, where a finite set of sounds or words can be combined in endless ways to create new meanings, makes it an incredibly powerful tool for thought and communication. The diversity of languages, with over 7,000 currently spoken, reflects both the unity and diversity of humanity. All languages share certain universal features, suggesting they stem from a common biological capacity, yet each language is also unique, shaped by history, culture, and environment. Children acquire language effortlessly, suggesting we are innately prepared for it, yet the specific language they learn depends on their environment. The study of language evolution, both the biological evolution of the language capacity and the cultural evolution of specific languages, sheds light on what makes us human and how we came to possess this remarkable ability. As sleep begins to enfold you more deeply, let these thoughts settle gently in your mind. Consider how every aspect of who you are, from your physical body to your emotions, from your cognitive abilities to your social behaviors, is the product of a long evolutionary journey. You are not separate from nature but a part of it, shaped by the same forces that have shaped all life on Earth. Yet you are also unique, possessing abilities and awareness that, as far as we know, are unparalleled in the history of life. This combination of connection to the natural world and distinctive human capacities is what makes our species so fascinating and our existence so precious. The story of human evolution is not finished. We continue to evolve, both biologically and culturally, responding to new challenges and creating new possibilities. The choices we make today will shape the future of our species and our planet. Understanding our evolutionary history can help guide these choices, reminding us of our connection to all life, our capacity for both cooperation and conflict, our resilience and adaptability, and our responsibility as the first species capable of understanding and intentionally shaping its own evolution. The migration of humans out of Africa and across the world is one of the greatest adventure stories in history. Imagine small groups of people, perhaps just a few dozen individuals, setting out into unknown territories, facing landscapes they had never seen, climates they had never experienced, animals and plants they had never encountered. Each generation pushed a little further, adapting to new conditions, developing new skills and knowledge. From Africa, they spread along the coasts of the Arabian Peninsula and into South Asia, following the shoreline and utilizing marine resources. They reached Southeast Asia and Australia, crossing ocean channels that required boats and navigation skills, demonstrating remarkable ingenuity and courage. Other groups moved north into the Middle East, and from there into Europe and Asia. They encountered the Neanderthals in Europe and the Denisovans in Asia, interbreeding with them and incorporating their genetic adaptations into the expanding human population. They survived the ice ages, finding shelter in caves, crafting warm clothing from animal hides, and developing technologies like the needle, which allowed them to sew fitted garments. They painted magnificent art on cave walls, creating images of animals with stunning realism and beauty, leaving us glimpses into their world and their minds. In East Asia, populations adapted to the local environments, developing technologies suited to the resources available. They created sophisticated tools from bamboo and other plant materials, many of which have not survived in the archaeological record, but which may have been just as important as stone tools. They domesticated the dog, creating a partnership between species that has lasted tens of thousands of years. Dogs helped with hunting, provided companionship, and served as guards, while humans provided food and protection. This relationship shows the human capacity for cross-species cooperation and may have been crucial in human survival and success. The peopling of the Americas represents another extraordinary chapter in human migration. During the Ice Ages, sea levels were low enough that a land bridge connected Siberia to Alaska. Groups of hunters followed game animals across this bridge into a continent devoid of humans but rich in wildlife. They spread rapidly southward, reaching the tip of South America within a few thousand years. They encountered entirely new ecosystems, from Arctic tundra to temperate forests to tropical jungles to high mountain plateaus, and they adapted to all of them. They hunted mammoths, mastodons, giant ground sloths, and other megafauna, many of which went extinct shortly after humans arrived. Though the degree to which human hunting contributed to these extinctions remains debated. The settlement of the Pacific Islands was one of the last great migrations, occurring within the past few thousand years. Polynesian navigators developed sophisticated techniques for ocean voyaging, using the stars, ocean swells, wind patterns, and the behavior of birds to navigate across vast stretches of open water. They carried with them plants and animals, establishing new populations on remote islands. They reached Hawaii, Easter Island, and New Zealand, creating cultures adapted to island life. The courage and skill required for these voyages, setting out into the unknown with no guarantee of finding land, speaks to the adventurous spirit that has always characterized humanity. Throughout all these migrations and adaptations, human culture evolved alongside biology. Different environments favored different technologies, different social structures, different beliefs and practices. The result is the incredible diversity of human cultures we see today, each representing a unique solution to the challenges of survival and a unique expression of human creativity and values. From the Sand people of the Kalahari Desert, with their intimate knowledge of the environment and sophisticated hunting techniques, to the Inuit of the Arctic with their ingenious adaptations to one of the harshest environments on Earth, to the Aboriginal Australians with their complex kinship systems and dreamtime stories, to the countless other cultures around the world, each has contributed to the rich tapestry of human experience. The invention of agriculture around 10,000 years ago transformed human life as profoundly as any event in our history. Instead of following game animals and gathering wild plants, people began deliberately cultivating crops and domesticating animals. This shift happened independently in several regions. The Fertile Crescent, where wheat and barley were cultivated, China, where rice and millet were grown, Mesoamerica, where corn was domesticated, the Andes, where potatoes were cultivated, and several other regions. The domestication of plants and animals was a gradual process, occurring over thousands of years as people selected seeds from the largest, most productive plants and bred animals for docility and other useful traits. Agriculture allowed for larger, more permanent settlements since people no longer needed to move in search of food. Surplus food could be stored, allowing some people to specialize in activities other than food production. Craftspeople, priests, administrators, and warriors emerged as distinct social roles. Trade expanded as specialized products were exchanged between communities. Writing was developed to keep records of transactions, leading eventually to literature, history, and science. Cities arose, becoming centers of power, culture, and innovation. Civilization, in the sense of complex societies with hierarchies, institutions, and cultural achievements, emerged from the agricultural revolution. Yet agriculture also brought new problems. Dependence on a few staple crops made populations vulnerable to crop failures and famines. Stored grain attracted pests and spoilage. Living in close proximity to domesticated animals facilitated the transmission of diseases from animals to humans, giving rise to new infectious diseases like smallpox, measles, and influenza. Social inequality increased as some individuals accumulated more resources than others. Warfare became more organized and deadly as competing groups fought over land and resources. The transition to agriculture was not a simple tale of progress, but a complex transformation with both benefits and costs. Human populations grew rapidly with the advent of agriculture, from perhaps a few million people worldwide at the end of the Ice Age to hundreds of millions by the time of the first civilizations. This population growth put increasing pressure on the environment, leading to deforestation, soil depletion, and the extinction of some species. At the same time, human ingenuity found ways to increase agricultural productivity through irrigation, fertilization, crop rotation, and selective breeding. The history of agriculture is a history of humans increasingly shaping the environment to suit their needs, a process that continues and intensifies to this day. The rise of ancient civilizations around 5,000 years ago marked another major transition in human history. In Mesopotamia between the Tigris and Euphrates rivers, city-states like Uruk and Ur developed complex governments, monumental architecture, and the first known writing system. In Egypt along the Nile, pharaohs ruled over a unified kingdom, organizing vast labor forces to build pyramids and temples. In the Indus Valley in South Asia, cities like Harappa and Mohenjo-daro featured planned layouts and advanced sanitation. In China along the Yellow River, dynasties emerged that would shape Chinese civilization for millennia. In Mesoamerica, the Olmec and later civilizations built cities and monuments and developed writing and complex calendars. These civilizations developed technologies and ideas that would shape human history. The wheel, the plow, metalworking, mathematics, astronomy, law, philosophy, art, and literature all emerged or were elaborated during this period. Trade networks connected distant regions, exchanging not just goods but ideas and technologies. Empires arose, conquering and unifying large territories, spreading languages, religions, and cultural practices. At the same time, inequalities deepened, slavery became institutionalized, and warfare became more destructive. The development of science and technology has accelerated dramatically over the past few centuries. The scientific method, with its emphasis on observation, experimentation, and the testing of hypotheses, has unlocked an understanding of the natural world that our ancestors could never have imagined. We have discovered the laws of physics, chemistry, and biology that govern the universe. We have developed technologies that allow us to manipulate matter at the atomic level, to travel faster than sound, to communicate instantly across the globe, to peer into the depths of space and the microscopic world of cells and molecules. Medicine has advanced to the point where diseases that once killed millions are now preventable or curable. Infant mortality has plummeted, life expectancy has increased, and quality of life has improved for many people. Yet these advances have not been evenly distributed, and billions still lack access to basic health care, clean water, and adequate nutrition. The challenges of ensuring that the benefits of progress are shared by all remain urgent and unresolved. The Industrial Revolution, beginning in the 18th century, transformed economies and societies. Machines powered by steam, then electricity, then fossil fuels, multiplied human productive capacity. Factories mass-produced goods that once had to be made by hand. Transportation and communication technologies connected the world in unprecedented ways. Cities grew into vast metropolises, housing millions of people. The pace of life accelerated, and the scale of human impact on the environment intensified. The burning of fossil fuels released carbon dioxide into the atmosphere, beginning a process of climate change that now threatens ecosystems and human societies worldwide. The challenges we face today, from climate change to biodiversity loss to nuclear weapons to artificial intelligence, are in many ways the products of our own success. Our technologies have given us unprecedented power to shape the world, but they have also created new risks. Our large, interconnected global population creates vulnerabilities to pandemics and economic disruptions. Our political systems, designed for smaller, simpler societies, struggle to address global problems that require coordination across nations and cultures. The environmental impact of billions of people living modern lifestyles is straining the planet's capacity to support us. Yet our evolutionary history also gives us reasons for hope. Humans have always been adaptable, creative, and resourceful. We have faced existential threats before and survived. We have the cognitive abilities to understand the problems we face and the capacity to develop solutions. We have the social skills to cooperate on a large scale when we choose to do so. The same intelligence that created these problems can be applied to solving them. The same capacity for culture that allowed us to build civilizations can allow us to transform them in more sustainable directions. The future of human evolution is uncertain and will be shaped by choices we make. Will we use genetic engineering to eliminate diseases, enhance abilities, or create fundamental changes in human nature? Will we merge with technology, integrating artificial intelligence and machines into our bodies and minds? Will we spread beyond Earth, establishing colonies on other planets or in space habitats? Will we find ways to live sustainably on our home planet, preserving the ecosystems that support us and the biodiversity that makes Earth so rich? These are not just technical questions, but ethical and philosophical ones that will require wisdom, foresight, and a deep understanding of what it means to be human. As you drift into sleep, reflect on the incredible journey that has brought humanity to this moment. From simple beginnings in the forests of Africa, through millions of years of gradual change, through ice ages and migrations, through the development of culture and civilization. Through triumphs and tragedies, our ancestors endured and adapted. They passed on not just their genes but their knowledge, their innovations, their stories, their hopes and dreams. You are the inheritor of this vast legacy, carrying within you the accumulated wisdom of countless generations. Your existence is improbable and precious. The fact that you are here, now, aware and conscious, able to contemplate your own origins and your place in the universe, is the result of an unbroken chain of events stretching back to the beginning of life itself. Every one of your ancestors survived long enough to reproduce. Every genetic combination that created them, and ultimately you, occurred successfully. You are a unique individual who has never existed before and will never exist again. Yet you are also part of something larger, connected to all of humanity and to all of life. The story of human evolution teaches us humility and wonder. We are animals, products of the same evolutionary processes that created every other form of life. We are subject to the laws of nature, dependent on the ecosystems that support us, vulnerable to disease and death. Yet we are also exceptional in our self-awareness, our ability to understand our place in the cosmos, our capacity to shape our own destiny. We are both part of nature and apart from it, both limited and limitless, both ancient and forever new. May this knowledge of our evolutionary journey bring you peace and perspective. The struggles you face in your daily life, the challenges and uncertainties, are part of the ongoing human story, a story of overcoming obstacles and adapting to change. The connections you make with others, the love you share, the knowledge you acquire and pass on, all of these continue the patterns that have sustained humanity throughout our existence. You are part of a continuum that stretches from the distant past into the far future, a living link in the chain of life. Sleep now, knowing that you carry within you the legacy of billions of years of evolution, from the first single-celled organisms in ancient seas to the complex, conscious being you are today. Rest in the knowledge that you are exactly where you should be, the product of countless generations of survival and adaptation, uniquely equipped to face the challenges of your time and place. Let the story of human evolution remind you of your resilience, your capacity for growth and change, your connection to something vast and enduring. Dream of the long journey of life on Earth, of the first stirrings of consciousness in our distant ancestors, of the gradual accumulation of knowledge and culture, of the spread of humanity across the globe, of the triumphs and struggles that brought us to this moment. Dream of the future that awaits, full of possibilities both wonderful and daunting, shaped by the choices we make and the values we uphold. Dream of your place in this grand story, unique and irreplaceable, a brief but brilliant spark of consciousness in the vast darkness of space and time. The journey of human evolution is your journey. The story of how we became human is your story. The future of our species is connected to your future, to the choices you make, the way you treat others, the legacy you leave. You are not separate from this story but a living, breathing part of it, carrying it forward with every breath, every thought, every action. Rest now in this knowledge, peaceful and secure, knowing that you are part of something beautiful and meaningful, something that has endured for millions of years and will continue long after you are gone. Sleep well, child of evolution, product of starlight and time, inheritor of an ancient lineage, creator of the future. Let your dreams carry you through the ages, from the primordial soup of early Earth to the present moment and beyond, always changing, always adapting, always moving forward. You are the universe contemplating itself, matter organized in such a way as to be aware of its own existence. This awareness, this consciousness, this spark of life and thought, is the gift of evolution, the culmination of billions of years of change and development. May you rest peacefully, carried by the eternal rhythms of life, connected to every living thing that has ever existed, part of the great web of existence that spans the cosmos. May the story of human evolution fill you with wonder and gratitude, appreciation for the long journey that created you, and hope for the journey that lies ahead. Reflect on the remarkable human capacity for symbolic thought, the ability to create and understand symbols that represent complex ideas. This capacity underlies language, mathematics, art, and all forms of abstract thinking. Our ancestors who painted animals on cave walls were engaging in symbolic representation, creating images that stood for the animals they hunted. Early humans who carved notches in bones to count the days were using symbols to represent abstract concepts like number and time. This symbolic thinking allowed humans to build mental models of the world, to imagine scenarios that had never happened, to plan for distant futures, and to communicate complex ideas to others. The evolution of symbolic thought was gradual, with precursors visible in the tool-making and social behaviors of early hominins. But somewhere in our lineage, perhaps with the emergence of Homo sapiens or perhaps earlier, this capacity blossomed into something qualitatively new. We became able to create entire worlds in our minds, to tell stories, to develop philosophies, to formulate mathematical theorems, to compose music. This imaginative capacity is perhaps our greatest evolutionary gift, the source of everything that makes human culture rich and varied. Consider the role of play in human evolution. Play is universal in human children and serves important developmental functions. Through play, children learn physical skills, practice social interactions, experiment with different roles and scenarios, and develop creativity and problem-solving abilities. Play is found in many animal species, especially mammals and birds, suggesting it has deep evolutionary roots. But human play is distinctive in its symbolic nature. Children create elaborate imaginary scenarios, pretend to be different characters, and construct complex narratives. This imaginative play may be crucial for developing the cognitive flexibility and creativity that characterize adult human thinking. The importance of storytelling in human culture cannot be overstated. Every culture has stories, myths, legends, and narratives that explain the world, teach moral lessons, preserve history, and provide entertainment. Stories allow us to share experiences, to pass on knowledge, to create shared identities and values. They help us make sense of the world and our place in it. The human brain seems to be wired for narrative, organizing memories and experiences into story form. This narrative structure helps us understand causation, predict outcomes, and learn from both our own experiences and those of others. The evolution of storytelling capability may have been crucial in the development of human culture and cooperation. Human beings are teaching and learning specialists in a way that no other species is. While many animals can learn from observation, and some can teach simple skills to their offspring, humans engage in extensive, deliberate teaching across a wide range of domains. Parents and other adults actively instruct children, not just allowing them to observe but guiding their attention, providing explanations, correcting errors, and offering encouragement. This teaching is cumulative across generations, with each generation building on the knowledge of the previous one. This cumulative cultural evolution has allowed human knowledge and technology to grow exponentially, far beyond what any individual could discover in a lifetime. The role of elders in human societies reflects the value of accumulated knowledge and experience. In many traditional societies, older adults are repositories of knowledge about history, ecology, technology, and social norms. They remember events from decades past, understand long-term patterns and cycles, and can provide perspective that younger people lack. The human tendency to respect and value elders may be an adaptation that promotes the preservation and transmission of valuable knowledge. Even in modern societies where some traditional knowledge has been replaced by formal education and written records, the wisdom that comes from lived experience remains valuable. Human beings have an extraordinary capacity for mental time travel, the ability to remember the past and imagine the future. This capacity allows us to learn from past experiences and apply those lessons to new situations. It enables us to plan ahead, anticipating future needs and taking action in the present to prepare for them. The ability to imagine future scenarios and their consequences is crucial for decision-making, allowing us to choose actions that lead to desired outcomes and avoid those that lead to undesired ones. This future-oriented thinking may have been strongly selected for in human evolution, as those who could plan and prepare were more likely to survive and reproduce. The human sense of time is complex and multi-layered. We experience time subjectively, with some moments seeming to pass quickly and others slowly. We measure time objectively using various methods, from the movement of celestial bodies to the oscillations of atoms. We think about time philosophically, pondering questions about its nature, whether it is linear or cyclical, whether the future is determined or open. The human relationship with time is shaped by our evolutionary history as creatures who must balance immediate needs with long-term planning, who must remember the past to navigate the present and anticipate the future. Human curiosity, the drive to explore and understand the world, has been a powerful force in our evolution and our history. Curious individuals who explored their environment, tried new foods, experimented with new techniques, and asked questions were more likely to make discoveries that improved survival and reproduction. At the same time, curiosity can be dangerous, leading to risky encounters and situations. The balance between curiosity and caution, exploration and safety, novelty-seeking and risk aversion, varies among individuals and cultures, reflecting different strategies for navigating an uncertain world. The capacity for innovation, for creating new solutions to problems, has been crucial throughout human evolution. Innovation often involves combining existing ideas in new ways, seeing connections that others have missed, or applying knowledge from one domain to solve problems in another. The innovative individuals in any population, those who develop new tools, new techniques, new ideas drive progress and change. Yet innovation also depends on a cultural context that preserves and transmits existing knowledge. The most innovative societies are often those that balance tradition and change, preserving what works while remaining open to new possibilities. Human aesthetic sensibility, our appreciation for beauty, may have evolutionary roots in the recognition of healthy, fertile mates, nutritious foods, and safe, resource-rich environments. But human aesthetics goes far beyond these functional origins. We find beauty in sunsets and starry skies, in mathematical equations and musical compositions, in stories and poems, in abstract patterns and harmonious forms. This aesthetic sense enriches our lives, provides deep satisfaction, and drives much of human creativity. The creation and appreciation of beauty may be one of the defining features of humanity, evidence of our capacity to transcend purely utilitarian concerns and find meaning and value in the world for its own sake. Sleep now, letting these thoughts settle gently in your mind like snowflakes drifting down on a quiet winter evening. You are a child of evolution, shaped by millions of years of natural selection, carrying within you the legacy of countless ancestors. You are also a cultural being, shaped by the society you live in, the language you speak, the beliefs and values you hold. These two aspects of your being, the biological and the cultural, are inseparable and together make you who you are. Rest in the knowledge that you are part of something vast and ancient, yet also unique and new, never before existing and never to be repeated. May your sleep be deep and restorative, your dreams vivid and enlightening, and may you wake refreshed and ready to continue your journey through this remarkable existence we call life. Good night, and may the long story of human evolution remind you always of your connection to all life, your capacity for growth and change, and your place in the great unfolding story of the universe.